All right, good morning or good afternoon. Today we're going to be doing 3.1 day 2. We're going to take it a step further. Yesterday's I can statements where I can calculate the rate of change given the table of values and a graph, and now we're going to determine if a linear relationship is proportional. That's what we're going to be doing today. So first we have to define a few things. A proportional linear relationship. First of all, it's going to be a line. So that means we're going to have that constant rate of change. But then the proportional part of it is going to be a constant ratio. So when two quantities have a proportional linear relationship, when they have a constant ratio and a constant rate of change, these graphs go through the origin. The origin is going to be that point 0, 0. So if our graph looks like this is our origin. If we have all four coordinates, it's going to be right smack in the middle. It's kind of a bad graph, don't worry about that. Again, our constant ratio is going to be the relationship between each y value and its corresponding x value. So if it's constant, it's going to be constant. If it has a constant ratio and a constant rate of change, it's going to be a proportional linear relationship. Okay. Again, I want you to be following along with your notes and filling them out. If you have questions, remember to write them down or raise your hand and ask them right away. You can pause it if I go too quickly. All right, you're going to be dividing your y by your x, the actual y point or each y value, not like we did before. So let's do a few examples. Okay, if I have a word problem like this, using the table to determine if there is a proportional linear relationship between a temperature in degrees Fahrenheit and a temperature in degrees Celsius, explain your reasoning. So the first thing I want to do is what we did yesterday with finding the constant rate of change. So I'm going to go and figure out from 0 to 5, it's 5, 5 to 10 is 5, 10 to 15, 5. I'm adding 5 each time. Then 32 to 41, I'm going to be adding 9. 41 to 50, I add 9. 50 to 59, I'm adding 9. 59, I'm adding 9 to get to 68. Each time I'm going 9 up. So the rate of change is going to be that difference. Remember, if they're not labeled, I want to label them X and Y. So the change in the y, so from 32 to 41, what is the change? I'm going up 9. And then that would be degrees Fahrenheit. And then my degrees Celsius is going to be unchanging, or the change is going to be 5. And that would be degrees Celsius. So my rate of change is the same each time, and it's constant. So it's a constant rate of change. So if I simplify this down, it would equal 1.8, and we're going to say degrees Fahrenheit, per, this is my degree sign, doesn't look like it, but per degrees Celsius. Now, I'm not just looking for if it is linear, I want to figure out if it is also proportional. So I'm going to look for and find out the constant ratio. And I'm going to be dividing the y value by the x value. So I'm going to do 32 over 0. And I'm not going to do that one, but 41 over 5, and that's going to reduce down to 8.2. 50 over 10, that's going to be 5. 50 divided by 10 You can use a calculator on these. Reduces down to 3.93 repeated. So already I know that these are not all the same, so it is not proportional. Can I spell? Because there's no constant ratio. Okay, let's try another one. Using the table, determine if there is a proportional linear relationship between mass of an object in kilograms and the weight of the object in pounds, and explain your reasoning. Okay, they're not labeled, so this is going to be my X and this is going to be my Y. The difference here, I'm adding 20 each time. So that's going to be 20. Now I know that if I add the same thing down here, I'm going to have a constant rate of change, which means it's going to be linear. So I add 9 to 9 to get 18, 9 to 18 to get to 27, and 9 to 27 to get to 36. So my rate of change is constant. So that means it's going to be linear. I'm going to do the change in the Y, 9 over 20. Remember to label 9 kilograms per 20 pounds. And if I reduce that down, I could change it to a decimal, but I really could just leave it like this and I would say per 9 kilograms per 20 pounds. Okay, now I want to see if I have a constant ratio. And if I do have a constant ratio, it is a proportional relationship. So I'm going to take 9 and divide it by 20. That's going to equal 0.45. Okay, 18 divided by 40, and that's going to be 0.45. 27 divided by 60, it's going to equal 0.45. And just for good measure, I'm going to check the last one, 36 over 80, and that's going to be 0.45. So because it has a constant ratio, it is proportional. Okay, let's do another one. Determine whether the relationship is proportional. Determine whether a proportional relationship exists between the two quantities shown in the table. So we're going to also be able to explain. This is going to be our same one from yesterday, but we're going to determine if it has a proportional relationship now. So yesterday we decided that it was six cans, because remember we're adding 6 each time. We're adding 5, so that would be 6 over 5, and that equals 1.2, and that's 1.2 cans per chair. So we do have a constant rate of change. Therefore it is linear. Now we need to decide if it is proportional or not. By finding the constant ratio. We're going to do 6 divided by 5. Does that equal 12 divided by 10 and 18 divided by 15? Well, each time I divide these numbers by these numbers, it is a constant rate of change. It is proportional because it simplifies down to the same thing. This is 1.2, 1.2, and 1.2. So yes, it is proportional because there is a constant ratio and a constant rate of change. We need both of these for them to be proportional, or have a proportional relationship. Okay, this one is kind of easy. It's going to say it's determine whether the proportional relationship exists. Right away, looking at these points right here, it doesn't go through the origin. Remember, this line has to go through the origin, so therefore it's not proportional because it does not go through this point right here. No work needs to be shown. All right, your assignment is page 175. We might be changing this, but that's what you can start on right now.